Hello guys, let us look at the derived quantities and units. In our previous video, we looked at the fundamental quantities and their units. You can find the link to that video in the comment section. So today, or in this video, we're going to be looking at the derived quantities and their units. So what are the derived quantities? The derived quantities are the quantities that are obtained from the combination of two or more of the fundamental quantities, while the derived units are the units of the derived quantities. So in physics, there are so many formulas, and all of these formulas are mathematical representation of the derived quantities. So we can say that all derived quantities have a mathematical representation called a formula, and we can obtain the derived units from this formula. So in today's video, we are going to be looking at a list of derived quantities, their formula, and their units derivation. So I have the derived quantities and the formula written out here, and we're going to derive the units in this video. The first quantity here is velocity, and the formula of velocity is displacement all over time. And this is a combination of two fundamental quantities, which are time and length. Even though length is not written here, we know that displacement is a measure of the length covered by an object. So we can represent this as length being the fundamental quantity, so that the units will become the unit of length divided by the unit of time, and that is meters divided by seconds. It can be written in this form, meters per second, or in index form, meter per second. Remember, in index notation, a negative index is also represented as a fraction. The next quantity here is acceleration, and the formula for acceleration is velocity all over time. Here, time is a fundamental quantity, and as we know, we've derived velocity, which is a combination of fundamental quantities as well, and so we can take the unit of the acceleration as the unit of velocity, meter per second, divided by the unit of time, second, so that we have meters per second divided by second. And if we evaluate this expression, we're going to get meter all over second times 1 all over s. When the division sign changes to multiplication, the divisor is represented in the inverse form, so that m times 1 gives us m, and s times s gives us s squared, and the unit becomes meter all over second square, which can be written in a better form as meter per second square, or in an index notation as meters per second square, that is meter seconds raised to power minus 2. Another derived quantity we are going to look at is force. The formula for force is mass times acceleration. Mass is a fundamental quantity, and the unit of mass is kilogram. So we're going to multiply the unit of mass by the unit of acceleration, which we've just derived, so that the unit of force becomes kilogram times meters per second square, where meters per second square is the unit of acceleration. We can write this in a better form as kilogram meter per second square, or in index notation as kilogram meter per second square, where the second square is written in an index notation s raised to power minus 2. Force also has a single unit of representation, and that unit is known as Newton, represented as capital letter N. Newton is the single unit of force. In physics, some of the derived quantities also have a single unit of representation, but each of these quantities and their units can also be represented in the kilogram, meters, and seconds form. But in the case of force, we have Newton as the single unit of force. Now, try this. Work is the quantity. The formula is force times acceleration. What will be the unit of work in meters, kilogram, and seconds form? Note that the single unit of work is the joules, represented as capital letter J. But try this, derive the unit of work in meters, kilogram, and seconds form. And please put your answer in the comment section. Remember to refer to our previous videos on fundamental quantities. The link is also in the comment section. Thank you very much for watching.